Alright, we're going to continue with our next lesson, and we finished looking at arithmetic sequences in series, and today what we're going to do is we're going to switch gears and look at what a geometric sequence is. So remember, with arithmetic, we were adding or subtracting a common difference. So that's what made that happen. So what we're going to look at now is a geometric, where instead of adding or subtracting, we're actually multiplying or dividing. So you can see in this case, we started at 2, and if we times 2, we get 4, we times 2 again, we get 8, times 2 again, we get 16, and so on. So in this case, we're no longer adding or subtracting, we're going to be multiplying or dividing instead. And that's basically the only difference. The formulas change as well, but we'll get to that shortly. So for a geometric sequence, let's look at this first couple here. So we got 1, -3, 9, -27, 81, and so on. So you can see we're timesing by 3 each time, but we're also changing signs. That means we're going to be multiplying by -3. So to figure out the next two terms, we'd go 81 times -3, which would be -243. And then we times that by -3 again. We get positive 729. Okay, and if we do the next one, you can see we have 1, then a quarter, then a 16th, and so on. So we're getting smaller. So in this case, we're actually dividing by 4. So when we go 64, 1/64th time divided by 4, we get 1/256 as our next term. Divide that by 4 again, we get 1/1024. Okay, so in this case, either multiplying or dividing, that's really the only difference. And what we do, instead of calling it a D, we call that a common difference for arithmetic sequences. We call this a common ratio instead, so we use R as our variable instead of D. And you can see when we follow this pattern, we basically have first term, and we times it by R, then we take that and times it by R again. So term 1, let's just look at a simple one. If I give you 2, 4, 8, 16, and so on. So our term 1 is 2. And in this case, our ratio is 2, so we times it by 2 times 2, gives us 4. The next one is 2 times 2 times 2, or 2 squared, which would give us 8. The next one would be 2 times 2 cubed, which is 16, and so on. So because the pattern works out that way, that's how our formula actually is derived. So we basically just take our first term, and we times it by the common ratio to the power of however many terms minus 1. The reason why we put the -1 is our first term, we want it to be just that number, so we want it to have R to the 0, because anything to the 0 is just 1. So we just have our first term, and then from there, term 2, and so on. We just multiply by the R, and that's it. So just like we did with the previous formulas, we can use this formula now to solve the similar kinds of things. So this first example, we want to find the 12th term. So we're looking for T12, so term 1 in this case is 512. Our common ratio, you can see we're dividing by 2 this time, but -2. So we'll write that as -1/2. And we want 12, so 12 minus 1. So on your calculator, just type in 512 times 0.5, -0.5, to the power of 11. And that gives us -1/4 for our final answer. So it's pretty small, but you can see we are getting smaller and smaller as we go, so that makes sense. Just like we did before again, we can do the general term. So that's just our T of n formula. So term 1 is 5. In this case, we're multiplying by 3. So we just write it to 3 to the n minus 1. And we don't do any simplifying. Just leave it like that. So let's try this next one. So our first term is -64. And we're dividing by 2, so we'll put that as 1/2 to the n minus 1. The next one, we got 128 as our first term. This one's a little bit weird to figure out what the R value is, so just divide them. Go 192 divided by 128. That gives us 1.5, and let's just double check. Go 288 divided by 192, and that gives us 1.5 as well. So our common ratio in this case is 1.5. And our last one, we have variables involved, but they work the same. So term 1 is m. What are we doing? We're timesing it by a cubed each time, so that would be our R value, and then n minus 1 as well. We'll do a couple word problems. So here we got population of Leduc grows 9% annually from 2001 to 2006. 2006 it started at 28,927. So we're looking we want to figure out what it's going to be in 2015. So from 2006, if we call that our term 1, 2015 would be term 9, right? 2015 minus 2006 would be 2015. So we want term 9, so our term 1 is 28,927. We're growing 9%, but we got to be careful of 9% as a decimal is 0.09, but we want to grow, so we want to add that to our starting amount, so we put it in as 1.09, and we do that to the 9 minus 1. Okay. Oh, I think we messed up a bit. 2006 is term 1, and we got to go another 9 years, so we'd actually want 10. Term 10 would be 2015, so we put 10 minus 1, which ends up just being the 9 in the end anyway. So anyway, let's try that on our calculator. So go 28,927 times 1.09 to the power of 9, and that gives us 62,826, rounded off. So now if we wanted to do 2030, the same thing. If we go 30 minus 6 is 24, but we want that extra term because we're starting with term 1 again. So in this case, we'd do term 25 and put the same numbers in, be 28,927, 1.09 to the 25, minus 1 would be 24. So let's try that on the calculator. Which gives us 228,844 people. So is that realistic? Probably not. That's a pretty big growth rate, but who knows? Only time will tell, I guess. So yeah, but just be careful in this case. So 2015 was our term 10, and then 2030 would be our term 25. Okay, here's another one. So it says we have our term 1 is 5, term 5 is 12,880. We're looking for term 2 and term 6. So let's start with that. We'll leave the second part later. So we got term 1 is 5, we got term 2, 3, 4, and then the next one is 1280. So remember in the previous stuff, we'd solve for D when we're doing one of these blank questions. Same thing applies, except this time we're going to actually solve for R. So R to the n minus 1. So in this case, put our 1280 as our last term again. Term 1 is 5, and we're going R to the 1, 2, 3, 4, 5. Subtract the 1 would give us 4. So to solve this, let's divide by 5 first. So 1280 divided by 5 is 256, and that's equal to R to the 4. So to solve that, we want to do the 4th root of 256, which is 4. So now that we know that, we can basically go into the question and plug in all of our missing numbers and solve for whatever we're looking for. So if our R is 4, that means we times by 4 would give us 20, times by 4 again we get 80, times by 4 again we get 320, times by 4 again, that gives us the 1280. So that's good. So we know in this case our term 2 is 20, that's our one answer, and it's asking for term 6, so we can times it by 4 again. That gives us 5120 as our term 6. So those two are done. So all we got left now is this second part of the question. It's saying if the last term is 2480, what's the total number of terms? So we can do the same thing. So let's plug this into the formula. So we have 2480. Our first term is 5. Our R now we know is 4 to the n minus 1. So we'll go 2480 divided by 5. Let's do that just like we did in the previous step. So that gives us 4096 equals 4 to the n minus 1. And we can't actually solve this. There's not a way that you guys know mathematically to solve this. But what we can do is do a little bit of guess and check. We just got to go 4 to the power of, and let's try 4 to the power of 5. That's too small. 4 to the power of 7 is too big. So 4 to the power of 6 is the correct answer. So 4 to the 6 equals 4096. So that means if we actually change it, we can actually see then 4 to the 6, 4 to the n minus 1. That means n would have to be 7 in order to give us that 6 for an exponent. So So just like what we were basically doing, we did arithmetic means, now we're just looking at geometric means, and it works the same way. So in this case we've got 16 and 144, and we want one number in between the two. So you can either guess and check, or if we use the formula, let's try that. We'd have 144 as our last term, 16 as our first term, we're looking for r, and n minus 1, so that'd be 3 minus 1, which is 2. So we just have 144 divided by 16. Gives us 9, and we square root that, we get 3, so we can go back to the question, and 16 times 3 would be 256, would be our middle term. Okay, so now same kind of question, we got 3, we want two numbers in between 3 and 625, so if we use the formula again, we'd have 625 equals 3, and r to the 4 minus 1, which would be 3. So 625 divided by 3 gives you a decimal. So there's actually a typo on this question, so let's clean this up a little bit. So it should actually have been 5, not 3. This is the way I had the original question. So between 5 and 625. So if we go 625 divided by 5, that gives us 125 r cubed. If we cube root that, we get 5. So now we can go back to the question. So we'd have 5 times 5 would be 25, times 5 again would be 125, and there's our two means. So here's another one, kind of the same sort of thing again. We don't know term 1, but we know term 2 is 20, don't know term 3, we know term 4 is 500, so we're looking for the general term and term 8. So we need to figure out what term 1 is, basically, and then from there we should be good to go. So we can use the formula again. We can go 500 divided by 20. That gives us 25 to the r squared. So I'll write that out. So we have 500 equals 20 r to, if we just look at, we're just looking at those three terms. So it'd be 3 minus 1 would be r squared. So 500 divided by 20 is 25. Square root that, we get an r of 5. So that means we'd have 100. And 20 divided by 5 would give us 4. So we know our term 1 now. So to do our general term, it should be term 1, which is 4. Our r is 5 to the n minus 1. And so that's our general term formula. And then our term 8 would be 4 times 5 to the 7. And we do that, we get 312, 500 would be our final answer. And that's it for this topic.